All right, let's take a real quick look at some of the reactions of our sugars. So one thing we can do is we can change the alcohols into either esters or ethers. So for example, if we've got our D-glucose, we can draw this a bunch of different ways. Feel free to draw it however you wish. I'm gonna draw it this way because that's the way I drew it in my notes. And then one thing we can do is acetylation to add an acetate group. So we'll add this excess of this anhydride, which sometimes gets abbreviated as just AC2O, some pyridine, and then basically we're going to swap out all these alcohol groups for these acyl groups. Right, where this AC is just this right there. And so we can see an issue, right? If we think about the mechanism of this reaction, it's going to have to do with these OHs as acting as nucleophiles. And then continuing the mechanism, so on and so forth. And so all of these alcohols are going to be nucleophilic. And so we can't selectively acylate either one of those. And the same thing goes for the ether formation. If we were to, I'm just going to draw a dash dash, same thing. If we were to add some, for example, some excess electrophile, just some methyl iodide, add a weak base. You can't add strong bases because then there's going to be other reactions with alcohol, where again, we're going to run into this issue where it's not selective. Right, so we're going to make methyl groups out of all of these. And there's just going to be no selectivity. Right, it's not selective, and it's not selective because all of these oxygens are nucleophilic. So the cool thing about biochemistry is that our bodies have created enzymes that can do this selectively. And in lab, there are advanced methods to do this selectively, but it's very difficult to do. And so while we can add these ester or ether groups, it's not all that useful because, again, we can't selectively do it because all of the oxygens are indeed nucleophilic.